Hello, my name is Zed Safchikova here, and in this presentation I examine the iconic mapping between semantic features for concepts and phonology in American Sign Language. The project I'll be talking about today is led by myself, Dr. Karen Emery, in collaboration with our research assistants Cindy Farnady and Brennan Terhune-Cotter at San Diego State University. This project is also a part of a larger collaboration with colleagues on the East Coast, Dr. Naomi Caselli at Boston University, Dr. Ariel Goen-Goldberg at Tufts, and Ariel Borowski at Purdue. This project receives funding from the National Science Foundation. People's conceptual representations vary across cultures and languages. Iconicity, which varies across languages, can support semantic representations by highlighting correspondencies between the phonological form of a word and its meaning. While all languages use iconicity, sign languages can modify their phonological forms to spatially represent the physical attributes of a concept. Now, the visual manual modality of sign languages affords more opportunities to map specific semantic features onto the articulators compared to spoken languages where such opportunities to match physical properties of reference onto the vocal articulators are much more limited. Now, one example of iconic mapping in spoken languages, for example in English, would be onomatopoeia. Iconicity in sign languages opens an exciting window to explore the nature of these mappings and how they are systematically mapped to the phonology of signs. In American Sign Language, the form meaning mapping can range from non-iconic signs, like mother, which looks nothing like mother, to moderately iconic signs, like cat, which only partially looks like a cat, to strongly iconic signs, like drink, which looks a lot like drinking. Iconicity has been quantified and measured in the past by obtaining subjective ratings, either from hearing non-signers or deaf signers, where people judge the degree of correspondence between the sign meaning and its form, giving it a rating on a scale where small numbers represent no iconicity or no form meaning resemblance, and high numbers on the scale represent a high degree of iconicity. But ratings only provide a holistic measure of iconicity, which may obscure the fact that only certain semantic features are iconically depicted in the phonological form. In this figure, I illustrate the mapping principle in more detail, using the example for the concept of bird. In this form meaning mapping, the extended fingers located at the signer's mouth can be structurally aligned with an image of a bird's head and beak, an alignable difference between the signer's articulators and an imagistic representation of a bird's head. The structural alignments between concept features and sign phonology vary across sign languages. An example from Turkish Sign Language for the same concept shows that it's the wings, the body, and the head of a bird that are aligned with the signer's articulators, but the beak is not depicted in the sign form. Other features are not as easily depicted, such as the color of the bird. So an interesting question arises, the one that we're pursuing in this study. What is the nature of the features that are depicted in the sign form? Are they perhaps more salient? This theoretical framework of structure mapping developed by Karen Emery allows us to formally account for the effects of iconicity on linguistic structure and processing. Unfortunately, there are currently no resources that provide information about semantic features for ASL signs themselves, but we do have feature norms for English provided by English speakers. In fact, English feature norms might be a good proxy for semantic representations in ASL because ASL signers are bilingual, that is, they know both English and ASL. And because there is a shared culture, so looking at the English feature norms might be a good first step to examine how semantic features map onto sign phonology. So to address this question, we capitalized on feature norms produced by English speakers, where speakers are presented with an English word representing a concept and must generate a list of features that relate to that concept. So for example, a cat has whiskers, is furry, lives in homes, and so on. Now, our objective was to quantify how many and characterize the type of semantic features that are iconically represented in ASL signs. For example, is it the case that the kinds of features that are visible in the sign forms are also the most salient or the most frequent features? We utilized two data sets of semantic feature production norms for concepts represented by English words. The McRae et al. Published a while ago in 2005, and the Peters, McRae, and Borowski, which is currently in preparation. Both norms provide a list of semantic features and feature production frequency, which is a proxy for salience, for living and non-living object concepts or nouns. The norms also provide information about the feature types, which are classified based on the brain region taxonomy provided by McRae, which is a rich data set that incorporated insights from neuroscience to determine the kinds of knowledge that is computed in somewhat distinct brain areas, like visual motion or encyclopedic knowledge or taxonomic knowledge, and so on. Now, we combined these two data sets and identified a total of 436 concepts for which there were good translation equivalents in ASL. So, for example, there's only one sign in ASL that corresponds well to the concept of elephant. But note that a number of concepts mapped to two or more ASL sign variants. So, for example, there are different ways to sign pineapple, and vice versa. There were distinct concepts that tended to be represented only by one ASL sign, for example, pistol. For each concept, the reference sign was retrieved from the ASL Lex database, and also for each of these signs, the database provides subjective iconicity ratings and subjective frequency ratings, so the lexical frequency of each sign. ASL Lex is an open source online lexical database for almost 3,000 ASL signs, and it's a collaboration among our San Diego team and teams at Boston and Tufts universities. And you can find this website, a beautiful visualization, on asl-lex.org. The procedure for this study was as follows. 3 skilled ASL signers, 2 deaf and 1 hearing, assessed whether the semantic features listed for each concept were iconically depicted in the corresponding sign. There was about 89% agreement among coders on all features. Here's an example for the concept shovel. You can see the list of semantic features provided by English speakers that I've sorted here in order of their production frequency, with features that are most frequently listed at the top to the least frequent features. So for shovel, 24 out of 30 people said has a handle. Next, our ASL signers went through this list and judged whether each feature is iconically depicted in the corresponding ASL sign. So for example, the features has a handle and used for digging were coded as being iconically depicted in the sign because the signer's hands depict holding a handle and perform a digging motion. But features such as is a tool or is made of metal are not represented iconically in the sign. We developed a set of specific guidelines and criteria to ensure that our coding was consistent across items and could be replicated by others. Ultimately, this type of semantic feature coding will provide a detailed quantitative and qualitative analysis of the semantic features that participate in iconic structure mapping for ASL signs. Of the 7,563 English features, only 14% were identified as iconically depicted in a sign phonological form. The distribution of iconic features across all 436 concepts that we coded is shown in the graph on the right, where you can see that few concepts contained a high number of iconic features, but the majority of concepts contain few or no iconic features. To illustrate with some examples, in some signs like sandwich, 70% of semantic features were iconically depicted in the sign. Sandwich was also rated as highly iconic sign by deaf signers. Other signs, more moderately iconic, like banana, contained only one or few features, where, for example, the feature has a peel or eaten by peeling, were depicted in the sign, but is yellow or grows on trees was not. Many non-iconic signs, like apple, did not depict any of the English features iconically. The next step was to quantify the relationship between holistic iconicity ratings and the number of iconic features, which I refer to as feature iconicity. And I quantified feature iconicity as the proportion of features depicted in the sign out of all features in the semantic feature list for each concept. In a regression analysis, I tested whether holistic iconicity ratings predict feature iconicity. And because these signs also varied in their frequency, I also included the frequency variable in the regression model. Our previous work suggests that highly frequent signs tend to be less iconic, so I wanted to see if frequency of use predicts the proportion of iconic features. So the first graph shows the relationship between holistic iconicity on the y-axis and feature iconicity on the x-axis. And you can see that there is a positive relationship between the two. This shows that iconic signs contained more iconic features. There was a greater prominence of English-based features in the form of more iconic signs. On the right side, I plotted the sign frequency on the y-axis and the proportion of features on the x-axis. And you can see that more frequent signs actually contained fewer iconic features. So the relationship here was negative. So this suggests to us that frequency of use reduces not only holistic iconicity, but also feature iconicity. And finally, going back to our question about what types of iconic features are depicted in the sign form, we looked at each iconic feature with respect to its classification in the Cree and McRae brain region taxonomy. To give you some examples, a feature type in the visual motion category would be an object flies or bounces. An example for the visual form surface category would be an object is small or has wings. And an example for the function category would be that something is used for digging. So we wanted to see if some feature types, based on this classification, were more prevalent due to the visual modality of sign languages. Now the results show that the most common feature types were visual motion, visual form surface, and function. But features relating to taste or visual color were never depicted in ASL signs. For a comparison, the most common feature types in English were visual form surface, encyclopedic, and function. In English, visual motion type, the most prominent type of features depicted in ASL, was actually not very common in English. So this suggests that the domain of movement for depicting motion might actually play a unique role in supporting iconicity in ASL. To summarize, holistic iconicity ratings are tied to the number of iconic semantic features depicted in the sign. So this study clarifies the gradients in holistic iconicity ratings. Frequent signs have fewer iconic features, and this replicated our former results with holistic ratings, where we found that frequent signs are less iconic. We saw that based on the feature types that are depicted in the signs, sign language modality might uniquely contribute to semantic representations in ASL, and this is something that we're planning to look at. Overall, the study provides clues to the semantic sources that support iconic form meaning mappings in a sign language. So what are our next steps? Our planned analysis will examine whether salient semantic features are more likely to be depicted in the sign, and whether the production frequency of semantic features, which is a proxy for salience, predicts holistic iconicity ratings. So this analysis should really tell us if it's the salience of the features, as opposed to the quantity of the features, or both, that drive the holistic iconicity ratings. And a separate study is now underway that is aiming to collect feature norms from deaf ASL signers for ASL signs themselves. And this study will uncover the ways in which the language modality influence semantic representations. So stay tuned. Thank you very much for your attention, and I look forward to your questions.